Hello guys, welcome back to my YouTube channel. As you all know me, this is Arshini with the USN 1VE23EC011 from Sri Venkateshwara College of Engineering, Bengaluru. I currently pursuing first semester in the Department of Electronics and Communication Engineering. I am here today with the subject called Applied Physics for Triple E stream. In today's video, I am going to explore you about the principle of complementarity and bond interpretation. This is the topic of today's video. So let's move on. Let us start with the introduction. Before knowing about the principle of complementarity and bond interpretation, or what is principle of complementarity and bond interpretation, as you all know, light has a dual nature, right? So you'll be little bit confusing that why I am telling this dual nature of particle. You'll know it later. So, dual nature of light, which means it refers its ability to behave as both as a wave and a particle. So, this is what is there in the principle of complementarity. This is what explained in the principle of complementarity and Born interpretation, that the dual nature of light refers to its ability to behave as both a wave and a particle, a concept that challenges traditional understanding of physics. This duality is explored through the principle of complementarity and Born interpretation, shedding light on the complex nature of light. That is, what is there exactly in the principle of complementarity and bond interpretation, or what is exactly explored in both these topics is the dual nature of light, how the light shows the dual nature, or how or what is about the dual nature of light is completely, or it is what explained in the this concept. Let us see what is the wave-particle duality. That is, this concept of wave-particle duality suggests that light exhibit characteristics of both waves and particles. This phenomena is exemplified in the experiments such as double-slit experiment, where light behaves as a wave when not observed and as a particle when observed. This concept of wave-particle duality explains that light exhibits both characteristics such as waves and particles, and this is well explained in the experiment called the double-slit experiment, where this experiment shows that light behaves as a wave when it is not observed and as a particle when it is observed. Now let us start with the actual topic, that is principle of complementarity. What is this principle of complementarity, or what it states is the principle of complementarity asserts that light can only be observed as either a wave or a particle, but not both simultaneously. Means it says that you can observe only a single property of a light, that is a wave or either a particle at a time, not both once at a time. This principle highlights the inherent duality of light and the limitations of classical physics in explaining its behavior. That is that this concept mainly focuses on the duality of light. That is why I have started in the beginning, or I have told you in the beginning about the dual nature of light. And now let us see about the wave function and Born interpretation. The wave function describes the probability amplitude of finding a particle, such as light, at a specific location. The Born interpretation of the wave function asserts or states that the square of the wave function provides the probability density of finding the particle at a given position. As I said, wave function describes probability amplitude. What is meant by this probability amplitude is it is the square of amplitude of wave function at some point which provides the probability of detecting a particle at the specific point or a location. And the Born interpretation, which states that the square of the wave function provides the probability density of finding the particle at a given position, means at a given position or at a perfect or position, it finds the particle, it finds the probability density of a particle. This probability density is given by taking the square of the absolute values of the wave function, of the given wave function. What wave function is given, so we will square the wave function at the absolute value to get the absolute value. So by squaring this wave function gives the probability density of a particle being at a particular place at a particular time. So this is what Born interpretation states or asserts. This study of light's dual nature or a principle of complementarity or wave functions, all this comes under the quantum mechanics, which is a part or branch of physics that describes the behavior of particles at the atomic and subatomic levels. Not only this, it provides a framework for understanding the wave-particle duality of light. We also have the experimental evidence for the principle of complementarity or the dual nature of light, that is a photoelectric effect and the diffraction of light, which provides the complete evidence for the dual nature of light. In these experiments, they demonstrate the wave-like and particle-like behaviors of light, confirming its complex natures. Now let us see what are the implications and applications on this concept. Understanding the dual nature of light has profound implication in various fields from quantum physics to technology. Applications include quantum computing, photonics, and fundamental research in understanding the nature of the universe at a fundamental level. Now let us come for the conclusion of this topic. The exploration of the dual nature of light through the principle of complementarity and Born interpretation has revolutionized our understanding of the fundamental nature of light. This duality challenges whole classical physics and opens new frontiers in quantum mechanics and technological applications. Means by this we can understand, or by the principle of complementarity and Born interpretation, we can understand the fundamental nature of light, or that is the dual nature of light. And this duality or this dual nature challenges the whole classical physics and opens new border in quantum mechanics and technological applications. So that is all about the today's video. Please like, share and comment on this video. Thanks for watching.